In this lesson, we're going to talk about solving quadratic equations by factoring. Section 1.5 covers solving quadratic equations by multiple methods. So the first method is solving by factoring. A quadratic equation would be an equation of the form ax squared plus bx plus c equals 0. That would be standard form. At this point, it's expected that you do have a solid understanding of factoring. If you need any additional practice with factoring, be sure to go back and review section P.5. So in order to solve an equation, a quadratic equation by factoring, first we need to get to the equation in standard form. And again, standard form would be ax squared plus bx plus c equals 0. So in this case, we have 3x squared equals 2x. It is not in standard form because we need to have it equal to 0. So I'm going to move the 2x over so that we have 3x squared minus 2x equals 0. Now second, we need to factor this. When we're factoring, we want to always look for a greatest common factor first, which we actually do have here. We have a greatest common factor of x. So when solving by factoring, no matter how you're going to factor, you want to start looking for a greatest common factor first. So I can pull out an x, which means that we're left with 3x minus 2 equals 0. Next, in continuing to factor, we want to try to see if we can factor the inside again. So inside our parentheses, I have 3x minus 2. I can't factor that anymore, so this would be the fully factored form of 3x squared minus 2x. Our next step would be to solve for x using our zero property of multiplication. Our zero property of multiplication says that a real number times 0 is equal to 0. So what this says is that if I look at my two factors, either, to make this a true statement, either the x can be a 0, because 0 times a real number, whatever would be inside the parenthesis, equals 0, or my second factor, 3x minus 2, can equal 0, because if 3x minus 2 equals 0, then we would have x times 0, which equals 0. So our zero property of multiplication is saying that either factor can equal 0, and it would make this statement true, which means that in order to solve for x, we would set each factor equal to 0. So that means I'm going to have x equal to 0. And then our second factor would be 3x minus 2 equals 0, and we would be just solving each of these parts. Well, x equal to 0 is already solved. This would just stay x equal to 0. For 3x minus 2 equals 0, to solve for x, I'd move the 2 over, so we have 3x equals 2, and then we would divide by the 3 to get x equals 2/3. So we have two answers then, that we would have x equal to 0 and x equal to 2/3. As a solution set, we can write this as 0, 2/3. And what that means is that if I plugged into the original, both sides would be equal to each other if I plugged in x equal to 0, or if I plugged in x equals 2/3, or using our zero property, if I plugged in 0 for x, we would have 0 times a real number equals 0, or plugging in 2/3, I would have a real number times 0 equal to 0. So here we'll do another example of solving by factoring. First, we need to get this into standard form, so I need to move the 4 over, so that way I have 2x squared plus 7x minus 4 equals 0. From here, I need to factor this. You can either use trial and error or the AC method. It's up to you. As soon as I see that leading coefficient, I can see that I do not have a greatest common factor that I can take out, which means that either you need to use trial and error or the AC method. I'm going to walk through the AC method, but if you'd prefer to do trial and error, guess and check, feel free to do it that way. With our AC method, as the name says, is that we're just going to be multiplying a times c. Now the a comes from the ax squared plus bx, and then the c comes from the plus c equal to 0 when we have our standard form. So here, that means that I'm going to be multiplying 2 times negative 4, which would equal negative 8. Our next step in using the AC method would be to find our factors of negative 8 that add to the middle term coefficient. So what I mean is I want to find my factors of negative 8 that add to this positive 7 that we had here. So going through my factors of negative 8 that add to a positive 7, that would just end up being 8 and negative 1. Now our next step is that we need to rewrite our quadratic equation that was in standard form using these factors of 8 and -1. So what we're going to do is we are going to rewrite the 2x squared plus 7x minus 4 equals 0. I'm going to keep my 2x squared. I'm going to keep my minus 4, our constant. But now I need to break down that plus 7x using the 8 and the -1 that I found over here. So I'm going to keep whatever the variable is. So since it was a 7x, I'm going to break this down, essentially splitting this up into two terms using the 8 and the -1 as plus 8x and minus 1x. So I broke down the 7x into plus 8x minus 1x. It actually does not matter if you put the minus 1x first and then the plus 8x, as long as you have them both there and you're keeping whatever the variable was from the 7x. So what happened was I broke down the middle. Now I have what looks like a longer quadratic equation. We have 4 terms. Whenever we have 4 terms, we can factor this using factor by grouping. So I'm going to rewrite what we have here. So we have 2x squared plus 8x minus 1x minus 4 equals 0. So with our factor by grouping, I group 2 terms at a time together, and we factor with greatest common factor within each group. So for 2x squared plus 8x, I could take out a GCF of 2x, which means we're left with an x plus 4. In our second grouping, I have minus 1x minus 4. So since our first term is negative, we would take out a negative. And even though it might seem like we don't have a greatest common factor, we do have a greatest common factor of 1. So I'm actually going to take out a -1. When we take out a -1, what happens is that our terms inside would change sign. So -1x would just become an x. The -4 would turn into a plus 4. If we did this correctly, then the inside of our parentheses from both pieces would be exactly the same. So it looks like we're in good shape because we have an x plus 4 and an x plus 4. Now from here, we're using greatest common factor again. I can see that we have an x plus 4 and an x plus 4. That's the greatest common factor. So I'm taking one of those out, right? One greatest common factor of x plus 4. And then what I'm left with is the 2x and the -1, which would be our second set of parentheses, still equal to 0. Now that we have the fully factored form, we're going to continue to solve for x using that 0 property of multiplication. So setting each factor equal to 0, I would have x plus 4 equals 0, and then 2x minus 1 equals 0. So for x plus 4, moving the 4 over, we would get one answer of x equals -4. Solving for x on the right, we would have 2x equals 1. Dividing by 2, we would have x equals 1/2. So as a solution set, we would get -4 and 1/2 as our final answer to the original quadratic equation.